How many?
3.
4? 4? Any advances on 4? Prove it. Show me how many triangles there are.
Okay.
Prove it. You may use this piece of material.
Acute.
Does anybody want
Acute.
Obtuse.
Yeah, acute obtuse.
Obtuse, that's quite a nice word.
What is the right angle?
And, I'm looking for a green square board. Did it come through? I don't think it did. It's behind the. Is it there?
Is it these ones?
No, really good. This sort of size.
No.
Behind the bookcase. And there are many ways to use these. Hopefully she's just bringing in a board now. I'm going to take 2 the same. Yes. And I'm going to put a little one here. What is this triangle called? 2 the same, and this one is smaller. Yes. If I were, and I would never do this to a student, going to poke somebody, is this a sharpish sort of poke or a not sort of sharp poke?
Sharp.
You recognise it as a sharp poke. Okay, if it's sharp poke, what are we calling it?
Acute.
Acute means sharp. Choice. If I take the same 2 sticks, because we started off with isosceles, right? Isosceles. No, comme ça. It's a green. It's a big green board.
It's not the thing with the. There's numbers and it's.
No, it has nothing written on it. It's just a big red board, and it's actually you push pins into it. That's what it is.
Is it?
Not pegboard. No. Okay. So if I thought that I'm going to open it just a little bit, I've got an isosceles triangle. What if I open it quite a long way to this sort of dimension there? What's this one called? An equilateral triangle. You're okay with that? So 2 the same, open it just a little bit. I'm going to call it an isosceles triangle. It's still an isosceles triangle because these still are 2 the same. But this is an acute angled isosceles triangle. Yes? And then I keep opening and opening and opening to this point here. I'm going to call it an equilateral triangle. Yes? Does everyone understand that?
Yeah.
Good. But now, still my 2, and I've opened it wider. What happens if I go to here? A right angle triangle. Okay, that's interesting. We've got a right angle triangle. Yes! Okay. Where was it?
Behind the bookshelf.
What did I say?
Underneath.
It didn't translate well into French. So.
Bien. 2 sides the same. A little bit apart, we have an acute angled isosceles triangle. 2 sides the same, a 3rd dimension apart, and we have an equilateral. 2 sides the same, apart so far that I have a right angle. And in German they call this a rectangle. It means right angle. It means good and proper. It means recht. It's you hold yourself recht. You are right. It's about being morally right. Have you thought about that before? At a right angle, it is a good angle. Thus. It could be wrong, but it believes itself to be right. So, but we're going to get even bigger. Even bigger. And this dude is going to be called... Would you like to be poked with something this big? This one here. What do you reckon? Would you like to be poked with that? Yeah, you like being it. This now is greater than 90 degrees, so it is blunt. It is a blunt angle, and that makes it obtuse. The Latin word for blunt is obtuse. Do you know any obtuse people?
Yeah.
They're kind of blunt. They say what they're thinking. Right. This piece of equipment's got all sorts of pins by which I could anchor things, and a whole lot of. You almost never see these guys now. They're sort of the gold pins. Do you
Yeah.
know what I'm talking about? Yeah. To join two things together, so you will have a lot of lovely play with that. And there are some pins that you can isolate and hold things down. Cool. I've sort of got three isosceles triangles here, haven't I? I've got an acute angled isosceles triangle. I've got a right angled, i.e. acute is less than right angled. I've got one that is right angled, and I've got an obtuse one that is greater than right angled. True? Mm-hmm. So if I were to take this understanding of angle, we could say that the angle formed this way here is acute, 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 right.
Yep.
Obtuse, 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 straight. And still looking at this angle here, reflex, 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 reflex. Okay? So those are types of angles, right? So we've got up until acute, up until right angle, which we call acute. We've got right angle, and we've got
Obtuse.
obtuse. We can't have straight in a triangle, because then we've lost an angle. Yeah? We don't have a knee left, we've got a straight leg. And we can't have a reflex angle in a triangle, but in some other shapes we can. So I'm comfortable with my acute angled isosceles triangle, with my right angled isosceles triangle, and with my obtuse angled isosceles triangle. You guys comfortable with that? Mm-hmm. Yeah? And now when I'm talking about the angle, I'm talking about the biggest angle. Because this angle here is acute. Would you agree with me?
Yep.
But the biggest one is right. So that's the one we're talking about. This angle here is acute, but the biggest one is obtuse. So far so good? I started off with 2 the same, and I ended up with 3 the same. Could I have a triangle where none of them are the same?
Mm-hmm.
We call that a what triangle?
Irregular?
Scalene triangle. A scalene triangle. This is a very famous case of a scalene triangle who Pythagoras totally ripped off, which we'll talk about in a minute. Mrs. Pythagoras did a lot of this work, but Pythagoras is claimed for understanding the specialness of this triangle here. It is a scalene triangle. This particular one is a right-angled scalene triangle. Would you agree? Because you understand Pythagoras and you know that the special case that's here. What's that? 5, yes indeed. A Pythagorean triple. Now, this triangle is going to be still different lengths, but not a right angle this time. This one's actually going to be an obtuse angle. I'll put it over here. You see that this is an obtuse angle. This angle here is bigger than 90 degrees. It might not be clear to you. Bigger than 90 degrees. Okay? And this one, 3 different legs. We want it to be an acute scalene triangle. This angle is smaller than 90 degrees. Acute angled isosceles, right angled isosceles, obtuse angled isosceles, equilateral, acute angled scalene, right angled scalene, obtuse angled scalene. Sciglione des autres?
How do you learn how to work out the degrees?
How do I learn?
No, I was in like from this.
Trigonometry. It's beautiful. It's all based on this.
Okay.
Trigonometry is a whole field.
So is there like something in this room that teaches us how to do that? Is that
Teaches you trigonometry.
that
Teaches you the relationship between sides and angle.
Yeah.
Yes. Do you want that now? Pretty massive. Trigonometry. This is where you're talking about sine, cosine, tan.
Yeah. Oh, no.
That you had to buy a calculator for?
Yeah.
And it had to be a
Scientific
Oh.
calculator.
Seriously, you don't need any of that stuff. I could show you it using this piece of material here. Just like that. Over and over and over and over again. Give you that sine or cosine or tan. Yo.
The one thing I'm stuck on is if you measure a triangle by the largest angle inside it, if you have an isosceles triangle, an acute, scaling triangle, wouldn't the two other inside angles be larger than the acute angle? Since the angles always have to equal 180?
Yeah, so what? They could all be 60, couldn't they?
Yeah, but that would be equilateral, wouldn't it?
Yeah, so could they be 61, 61?
But if you're measuring it by the largest angle,
Yeah.
you'll never have an acute triangle because there's always going to be angles that are more than...
Why? What if I made this just slightly smaller?
Then the bottom two angles would be larger than the top angle, wouldn't it?
They might be, yep. But they're still less than 90.
That's true, yeah, they might.
Right?
Yeah,
Good, 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 good. Yes, he's right. If I drew a picture of all of these and ripped off the corners, put them all together, they'd always create a straight line. Always. Okay. So does this make sense? How many triangles are there in the world?
seven.
Do you think if we wait long enough, science will invent a right-angled equilateral triangle?
Probably.
That could go here. Can you see that I've got all these guys are acute, all of these guys are right-angled, all of these guys are obtuse, all of these guys are isosceles, all these guys are equilateral, and all these guys are scalene. But there's nothing here. What about an obtuse angled equilateral triangle? Will that ever happen? It cannot.
Why not?
Two 90-degree angles, a legal all angles would be the same if you've got two 90 degrees.
Yeah.
Is that going to make a triangle?
Oh, square.
Yeah, you add another 90 degree, it doesn't make a triangle.
No. Okay.
Because it's got three angles.
It
in
won't.
that.
Not in Euclidean maths, anyway. But then, of course, there is geometry that you can do on the surface of a sphere.